Hi everyone. So today is gonna be our day three of the DSA challenge that I took, right? And so without any further ado, we can probably shift on to the question. And the question that we're gonna do today is next permutation, right? So this is the link, this is the question, right? You can probably read about more of it. Let's go on to the lead code position of it. And let me remove this. Sorry for the inconvenience. Yeah. Great. So let me remove this part as well. Now, what does this next permutation say, right? So before even reading the question, let me tell you what exactly permutation is, okay? So let's just say, let me use this one, right? If we are given three positions, right? And what I'm saying is that you can only fill one, two, and three, right? These are the elements that you can put in these three places, right? You can rearrange it. You don't have to reuse the elements. Though, I mean, you cannot say 3, 3, 3, 2, 2, 2, 1, 1, 1, or 1, 1. Like, I hope you get my point. What I'm saying is, you just have to say, you just have to fill these positions with one of these elements, right? So, how many, uh, what are the permutations basically? Like, how many types of, uh, what do you say? How many types of basically कितनी बार तुम कर सकते हो, right? Like how many things you can fill it in, right? So what we can do is we can have, right? I can have comma here. I can put one, sorry, two, three, right? I can have 2, 1, 3. I can have 2, 3, 1. I can have 3, 1, 2. I can have 3, 2, 1, right? So 1, 2, 3, 4, 5, right? Oh, am I missing something? 1, 2, 3. Oh, sorry. Yeah, you can have 1, 3, 2 as well, right? Great. So how many positions can be set into it? So it is how many So there are six total permutations that can be rearranged. Like how many times you can rearrange these things to get a new set of an array, right? So this is three. So a general formula for this thing is for people who may have not known, who may not know this or probably are new to this concept. So there are n factorial of times that you can, have a new type of an array, right? So you can have what n is. N depicts the number of elements, right? You can have n factorial. Great. Now let's jump onto the question. A permutation of any array of integers is an arrangement of its members into a sequence or a linear order. Like I mean, it's just potato and potato. So for example, an array 1 to 3 can be said 1 to 3, 1, 3, 2, this thing, this whole thing. And these are six ways, right? So the next permutation of an array of an integer is the next lexicographical greater permutation of its integer. More formally, if all the permutations of array are sorted in one container according to their lexicographical order, the next permutation of that array is the permutation that follows in the sorted container. Let's understand what this exactly, right? So, okay. So 1, 2, 3. Let's just say we are given this as an array. What should be the next lexicographical rearrangement of this array? So I can obviously say that 3, 2, 1 is also a permutation of it. 2, 3, 1 is also a permutation. But is it lexicographically growing? That's the question? Now, what does lexicographical mean? To understand what lexicographical means, let's say we are given three names. Okay, one is ABC, one is ACB, and other thing is BAC. Okay. So you will notice that all three of the words contain only same letters, but they are rearranged. Uh, they are rearranged in their elements, like in their the indexes are rearranged. Now, can we say that ABC in a dictionary? Assume that this is a dictionary. Now, can we say that ABC, sorry, that ABC will always come after AC? Sorry, ACB will always come after AB. Now, why am I saying this? So assume that A is the maximum, is the longest common prefix of this array, right? This is the longest common prefix. So A is here as. Is B there? No, because the next thing is C here. Which is greater? We'll see. Is B greater than C? No, right? Because C is always greater than B. So obviously ABC will come before ACB. Now, if I was given, assuming I was given A, B, C, D, and I was given A, comma, B, comma, D, comma, E, right? Doesn't really matter. You just need to figure out what is the longest common prefix. Now, what is the prefix? That I mean, this is a very simple term. I don't know how to explain this thing, but I hope this is self-explanatory, like what prefix is. So A is common here, B is common here. Is C and D common? No, right? Because C is equal to D. No. So C is greater than D. No. Is C lesser than D? Yes. So lexicographically, in an increasing order, C will always come before D. ABC will always come before ABD, and that is why this word comes before. Great. So I hope this was kind of clear to you, right? So let's just understand now what we need here, right? We can, like I was explaining to you guys, that 1, 2, 3 can be rearranged to 3, 2, 1. But is 3 to 1 the next permutation, or can also be arranged to 3, 1, 2, 1, 3? Is 2, 1, 3 the next permutation lexicographically? We need to have the exact next, like 1 plus 1, right? If it was this 1 to 3 was to be rearranged and was in an array, right? This is an array, and this is the parent array which contains all the possible permutations. What would be the next possible permutations that would come? And this would be our answer, right? So to solve this question, what you can probably do is, like a brute force thing would be, brute force would always be brute force, right? So what brute force is, let's do nothing, right? Let's have this array 1, 2, 3, and let's fill and a let's have an answer array which is an empty array. This is gonna be our parent. This is gonna be a parent, right? Which will contain all the possible permutations. So let's do one thing. Let's have all the possible permutations and array dot sorry, answer dot push all the possible permutations. Great. Now, if I do that, can I linearly search like where this position is, right? Let's just say we are given with, oh sorry, we are given with 3 or 4 random places, and we need to fill random numbers. So could be number 1, number 2, number 3, and number 4. Could be anything, right? Just it could be anything, and we need to arrange them in this order, right? So to get all the possible permutations, we would require to use what do you call it? We would require to use recursion over here, right? I think we don't need this recursion here. I mean, that way you obviously would require to use recursion here, and you would need to find the most common. Like you need to have an index where all the things are changing and all the bullshit things. So before even going to code, let's kind of figure out like what the time complexity gonna be about this approach. So first, let's have all the possible permutations. Now, second, let's linearly search the given param, right? The given array. Return answer of index plus one, right? I am assuming that you would you would possibly uh, what I'm saying is you would possibly uh, when you will get all the possible permutations, right? You would possibly get sorted uh, form of answer, right? You would get, let's assume that the answer is sorted somehow, and the possible permutations that you get are sorted, right? You will linearly search the param. Let's just say this 1 to 3 is present at a position called 1, right? First index is present. Second index, basically, the first index would be a answer 0, sorry. So return index plus 1. So you would return the next thing because the things are sorted, right? The things are lexicographically flowing, lexicographically flowing. The next index would be the answer. Now, what would be the approach? What would be minimum? I'm saying the minimum time complexity, right? To get all the possible permutations, I told you that you can rearrange all the things in n factorial of time, right? So I would assuming that your answer, that your function, that the recursion function that you would probably make would run in at least, I'm saying that at least in n factorial, correct. Then you would go on to the second part. You would linearly search. That would require n O of n, big O of n. So this is the at least mm, uh, time complexity that you would require to probably do this do this question. Do you think that this is the optimal approach? I think not, right? So probably you won't even require to give all these such answers in an interview. You would simply just mention this approach, and then you would see, then you would say that yes, I can probably uh, see, I can improve the time complexity. I can go on to a better approach. Now, to go on to a better approach, I am not really sure like how to do it in C++ and JavaScript. I think there is a STL library in C++ where you can do things, but I'm really not sure of it. So I won't even mention it here. So let's move on to a better approach, right? The most optimal approach that we have here. Great. Uh, so to have uh, an array, right? Let's assume the array that is given to us is this 5, 4, 3, 0, and 0. And let me give shout out to Fiverr, obviously the one the person whose SDA sheet that we are using right now. So this example was given by him. You can probably go on to his videos and you can search more about it. So great. So this is the array, right? Let's see. Let's start from the end. Now, this is an hint that I'm probably giving you before even starting of the question, before even starting of the um, approach, that you need to start from the end and you need to figure out the most common prefix where you would notice that all the things after it are sorted. Right? All the things after it are sorted. So, if anything from here, okay, let's not even start from here because we don't have any index here. So let's probably remove this and let's start from n minus 2. Okay. So do you have, is 0 greater than 0? Great. Let's shift this thing to here. Is 3 greater than 0? No, it is not. Let's just say we keep uh, these things as common prefix. So is this sorted? Sorry, yes, this part is sorted. Great. So let's probably move this to here. Great. Is 4300, is it sorted? Yes, it is. Or probably what you can do is you can uh, you can figure out that this is the most common prefix, right? And this is the part where you need to check that is it sorted? Yes, it is kind of sorted, right? Because 4 is greater than 3, 3 is greater than 0, 0 is greater than 0. I mean, is it? I hope it is clear to you guys that it is greater than equal to 0, right? Yes, this part is sorted. So we shift to this part. Sorry, we started from here, right? This is this part and this part sorted. Sorry, this is a common prefix, and this is a sorted array that we need to check. Yes, it is sorted. Great. Then we probably move till here. So let's remove this. So is this is the common prefix, and this is the part where we need to check that is it sorted? Yes, it is sorted. Great. We don't need to do anything. So when we kind of shift to this part, right, where 2 is the only common prefix, and we need to check this whole array that is it sorted. Let's check. 0, 0, sorted. 3 added, sorted again. 4 also added, sorted, because there is nothing that is greater than 4 in this part. Great. 5, is there any part that is greater than 5 in this position? No. But 1, is anything greater than 1 in this part? Yes. 5, 4, 3. These three things are greater than 1, right? But like I told you in the beginning of things, like we need to have a lexicographical order, right? So let's just do one thing. Let's have this index called uh, let's store it somewhere, right? Let idx equal to 1, because that is the breakpoint, right? This is the breakpoint where things start to get unsorted, right? I hope this makes this thing is clear. Now let's do one thing, okay? Let's start. So we found this is the common prefix, and from this is the breakpoint. Breakpoint, right? So this is the breakpoint, and what we will do is we will simply just find from this position till here that what is the next greater element. Now, how do we do that? Great. Let's just say if I have this thing, dot dot dot, spreading things, 5, 4, 3, 0, 0. So now, if I start from this position, is 5 greater than 1? Yes. But is it the next greater thing? Not sure. So let's store it. Or maybe let's not store it somewhere. Let's see. Let's move on. Let's find 4. Is 4 greater than 1? Yes. But is it the next greater thing? Not sure. See. Let's see. 3 is greater than 1? Yes. Is it the next greater thing? Let's see. Let's see. Let's say that 3 is stored here. 0, is 0 greater than 1? No. Is 0 greater than 1? No. So we found that 3 is the next greater thing from this part, right? Now, how do we kind of figure it out? So, okay. Let's say that we are here. We we start from this position. Sorry, we start from this position, from end of thing, right? Now, can we figure out the next greater thing? I I know we can do that because we figured out that from that break point, eh, till that breakpoint, everything was sorted because that is a position, right? That we because of which we came at this breakpoint, right? The one that was here. So we know that if we start from here, the first greater thing we get will be the next greater thing after it, right? So 3 will be the first position that is greater, and then we'll break the loop. We'll simply break it, and we know that 3 is the next possible thing. So if here was 1 and this is 3, let's simply swap all these information. So how does our array look like now? It would look like 2, 3, 5, 4, 1, 0, 0. Great. Just, just we don't need to check anything because we already know it. But just to make it more intuitive, let's just say here was a breakpoint, right? Sorry, this this position was a breakpoint. Now, after these things, when we what do you call it? When we swap things, is it still sorted? Yes, it will be still sorted, right? Because this was the lowest position, right? And even if we uh, what do you call it? Even if we swap things, right, we will still get the sorted array. So 54100 is always going to be sorted. Now, simply, what we can do is we can reverse this part and we can simply return like what exactly is our 00154. If I reverse this part and what was my parameter? It was 2, 1, 5, 4, 3, 0, 0. Can you say that this is the next exact lexicographical order that we need to that we needed to find? Yes, because one, 2, 1, let 2, 1 be common. Let 5 also be common. Let 4 also be common. Let 3 also be common. Now, why are we making it common? Because we would notice that from this part, everything is sorted. So if, like I told you in this part, right, we would start from n minus 2 and check at this position. Is this position sorted? If that position is sorted, then we move on to the next position. But if that is not possible, then we know that this is a breakpoint because this is breaking our what do you call it? This is breaking our graph. This is breaking our lexicographical graph, right? So we would say that this is the next possible uh, permutation, and we would return it. Great. We are done with it, but we still need to have one edge case that we need to figure out. You would notice that there is one example that is given. So 3 to 1 is the last possible permutation, right? In lexicographical order. So what is the output here? 1, 2, 3. So we would exactly go back to, sorry, we would exactly go back to 1, 2, 3 and dot, 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 3, 2, 1, right? We would have to go to the first position. Now we would obviously handle this part, but I hope this is clear that when you reach the last thing, when you know that is sorry, we would start from n minus 2 position, right? Okay. Is it sorted? Yes. We shift to this position. If this is sorted, this is sorted. We move to this position. Is the position is area of minus 1 a position? No, right? So we would obviously know that the position. This is the last position. Then we would return simply the first element. Now, how we will do it? Let's directly jump onto the code and we will notice. Great. Let just to know like what is the length of the array given. Let's say let nums dot length is equal to n. Great. And let's have an index. Now I am initializing it with minus 1. Now, what exactly index is? It will give us the break point, right? So let's run a loop from equal to n minus 2. I is greater than equal to 0, I minus minus. We are starting from the last position. Sorry, the second last position. Great. We would now see that if our array if nums of I is lesser than nums of I plus 1, right? So we would note, like we were going from this position, right? Is this is sorry, we were here, we were at this position. Is this lesser than this thing? No, we would move to here. Is this lesser than this? No, we would move it here. There dot dot one. Is one lesser than five? Yes. This is the position where we need to figure out. So index would be equal to I, giving basically we found our break point. And we would simply break the loop because we know that from that position, that is the most common, maximum common prefix that we would get. Great. We would come out of the for loop. Now let's have our edge case. Sorry, sorry for the spelling. Edge case check. Now, if index is still equal to -1, we would notice that this is the last possible permutation. Then we would simply return nums of reverse, reverse, right? Because we know that 3 to 1's reverse is 1, 2, 3, and that's the first position, right? That is the exact first position. So this is inbuilt function. You can read more about it. Great. Okay. So now that we know that index is not -1, it is some position. So what we'll do is we will start from let I is equal to n minus 1. It will go till n, sorry, index plus 1. Why it will go till index plus 1? Because we know index idx is the breakpoint. So after that, we need to find the next possible greater thing that is just greater than index, right? Array of index that is just greater than array of index. I minus minus. If a sorry, why am I doing array? So if nums of I is greater than nums of index, we would what we'll do is we will just so at this position we would need to swap. Why is my laptop running so slow? Swap the position, right? Now, how do we do it in JavaScript? I hope you guys already know about it. So so let's open these arrays. So array of, why am I saying array? I should say nums. I'm really sorry for my laptop, guys. So array of nums of I, nums of idx is going to be nums of idx, nums of I. So this will swap, right? And we would break out of it because we have already swapped this, so we don't need to go further, right? Now we will do one thing. Now, if you noticed here, right, when this was our, sorry, guys, just give me 1 second. Delete. Great. So, when we were at this position, so currently in our code as well, where are we? We are at this position where our things are swapped. So 2, 3, 5, 4, 1, 0, 0. So this is the 1 and 3 has been swapped. Now, what do we exactly require? We just simply need to reverse this array, this part of the array, and we will simply get it. We will simply get it, right? So if we say 2, 3, 1, sorry, 0, 0, 1, 4, 5. Is this the next possible thing? Is this the required answer? Yes, right? So now I have one formula for you guys. So let's understand this formula. Really sorry. Let me let's move here and let's let's simply see. So let's just say if array is given as 1, 2, 3, or let's say it is given as y. Let's take our generic example that we were having. So 2, 3, 5, 4, 1, 0, 0. We are at this position right now, right? We have swapped the things, but we need to reverse the order, right? So this is our array. So array dot splice. Now what does splice do? Basically, it adds a thing in your array, right? So if I say array of splice of 1 comma 0 comma if I say 6, right? So what it will do? It will add something on one first position, right? So it will be 2, 6, 3, 5, 4, 1, 0, 0, right? This will what it will do? It will add 6 at the first position. Great. So what are we saying? We are saying here that slice it from starting from index plus 1, and this is a delete count parameter, right? So what we need to delete and then add there. Are we deleting anything? Yes, we are deleting. So how many positions are we deleting? That would come here. So it says n minus idx minus 1. So what is n right now? 1, 2, 3, 4, 5, 6, 7. So n is 7. 7. idx was 1 and 1 minus 1. So it is equal to 5, right? Simple. And I'm spreading my whole array dot splice off. What is splice now? Now splice gives you the cut. Uh, I mean, how do I explain this to you? Great. So array dot splice mdn. Great. It changes the contents. No, I'm not. I had to have slice and not splice. Sorry. So let's go here. Instances return a shallow copy of a portion of an array into a new array object selected from start to end, right? It gives you a shallow copy of that position from that position till the next possible position. Then from start till end, right? So we were here, right? So I am from which position I'll do? I'll do from index plus 1. What is index? Index is 1 and plus 1 would be 2. So from 2 dot reverse, right? And if you don't give the end position, it will obviously by default take the last position of the array, that is the n minus 1 position, or n, because n is not included. So n minus 1 will be the last position. So we don't need to give that. And then we simply reverse it. Now, how do we reverse it? Starting from second index. Now, what is our second index? Let's see. 0, 1, 2. From this position till this position, and we reverse it. Great. That is what we required, right? That is what we required. So if this was a thing, now what it will do, it will simply uh, spread what? It will simply spread 1, mm, sorry, 0, 0, 1, 4, 5. This is what it will return. This slice part, what it will return, it will simply return this thing. Great. Uh, So what we need basically, what is the third parameter that in splice, third parameter is the thing that we are going to add, right? And this is the deleting of things. How many things are we deleting? So how many things are we deleting? 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5. 5 things that are needed to be added, and those will be the positions that will be deleted from array, right? So array dot splice Which position are we going to add from? 1 plus 1, that is 2. So the second position at second index 0, 1, 2. From 2, we are deleting 5 things and we are adding this array, right? So what it will return? It will simply return you 2, 3, 0, 0, 1, 4, and 5. We are not going to add this thing because we are spreading it, right? We are spreading these things. So this will be added into a shallow copy and this will what will be returned. Great. So simply say that array dot flies index plus 1. From that position, we are deleting n minus index minus 1 things. We are deleting n minus index minus 1 uh, elements and we are adding simply spreading the array dot slice. Now what it will return? It will return from start position till the end position of that array. What it will return? It will give me, so from n, sorry, from index plus 1, it will return me and we just simply need to reverse that part. I hope this is clear and we don't need to use array, we need to use nums here. Great. And simply let's return nums. And let's check that is this code running. Great. We are having one. We are having, we don't, we are not having the right answer here. Let's figure out what is the problem here. Okay. Uh, okay. Output is 1, 2, 3, but we expected 1, 3, 2. Okay. Why is it so? Nums dot slice index plus 1 n minus index minus 1. Uh, sorry, sorry. Am I using the right position? N minus index minus 1, array dot slice, reverse index plus 1 dot reverse. Okay, I think this formula is right, but are we, so what is the third? 115, 1 is, let's start from here, is 1 greater than, so this is the breakpoint, okay? And if this is the breakpoint from this position, we will have it. Let's figure out, are we getting the right index? Console index, right? And let's console here nums as well. Like after the swapping position and after it. 1, 2, 3, we are getting index as 1. Great. 1, 2, 3, 3, yes. And why is nums not, why is nums not console? Are we not reaching at this position? Are we reaching here? Even I am here. I am sure that this is going to be a very silly mistake. Okay, I am here, but nums of I is greater than nums of index. What is the problem here? Let's see. Let's see. I'm sorry, guys. I think you must have already noticed this, that we needed to have equal to here, or we could simply say greater than index, because we don't need index position because we already know that that is the breakpoint. After that, we are finding things. So we can simply say this. Now let me remove this and let me remove all the console logs and here as well. And now let's run it. Already I've run it for you guys, but yeah. Let me this floating panel. Yes, great. All the test cases are passed. Let's submit it. And great. So this is submitted, and it beats 41.24% of users of with JavaScript. So let's quickly understand what is the time complexity of it. So let me copy this whole code. Let me copy this whole code and figure out. Let's figure out, right? Let me make it more smaller so that it fits in in one thing. Yeah, it is. So this loop is running for O of n, right? This reverse thing is kind of also doing O of n time complexity. This loop again is running till from in O of n. Great. This reversing is O of 1 simply not needed. This splice thing is running from is this slice thing is adding things and is you know slicing things from here as well. So also running in O of n. So one, two, three, four. So we are kind of taking O of 4n time complexity. Great. Now what is the space complexity? Constant, constant. Are we using any other thing? We are not using any other um, any extra space. We are just simply doing all the things in place. And what was also mentioned in the description as well, if you check, the replacement must be in place and to only use constant extra memory. So the space will be O of n, right? So this is the time complexity. This is the space complexity. I hope I was able to make you guys clear that what exactly the whole solution should look like. I am really, uh, I'm relieved that I've finished this question. Or it took me a long time to figure out like how to do things. I'm not gonna lie, I had to search on the internet like how to exactly do this question in an optimal manner. Because obviously the brute force thing that where you use recursion, that is quite easy. And you would not even required to do that in an interview because making use of a function that requires recursion would kind of take you more time, right? Would take you at least 30 minutes or 45 minutes to think of the approach and then explain to the interviewer because you need to create the whole recursion stack and everything, right? I hope this thing got clear. Let's meet tomorrow with another question. Thank you so much. Before we go on, we need to set it as done. Great. Thank you so much, guys. Thank you for tuning in. Let's see you tomorrow. Bye bye.